This is now our trig review number 3, where we continue with our definitions. In particular, we're looking at the unit circle and the functions cosine theta, sine theta, and tangent theta. We're also going to include in here, now remember the definitions for x, y, and y over x. But for this video, we'll also include the reciprocal functions, reciprocal functions, and that would be the secant of theta, the cosecant of theta, and the cotangent of theta. And since these are reciprocals, I've lined these up. So the reciprocal of the, let's see, let me do that in green. The reciprocal of cosine, it's going to be 1 over x. And the reciprocal of sine is going to be 1 over y. And lastly, the reciprocal of tangent is going to be x over y. Okay, so with these additional, and again, for all the reciprocal functions, you need to note, not defined if denominator equals 0. We should probably have noted this also way back over here for the tangent. The tangent was undefined if x is equal to 0. And, you know, where would that occur? If you think about a circle, x is equal to 0 at the top of the circle here and here, you know, ordered pairs being 0, -1 at the bottom and 0, 1 at the top. So if we actually had an angle that had a terminal point at the top of the circle, and we asked what was the tangent of that angle, we would have had problems. So the tangent of theta in this case would have been undefined, right? Because the ratio of y over x would have led to the nonsensical expression 1 over 0, which doesn't mean anything at all in mathematics. So certainly, if you're dealing with an angle that terminates, the terminal side of the angle is either the top or the bottom of the circle, we'll call this one phi again, the tangent of phi would be undefined. Okay, and that may occur frequently over here with these reciprocal functions. Notice that the secant would be undefined when x is 0, the cosecant would be undefined when y is 0, and likewise the tangent would be, or the cotangent would be undefined when y was 0. Okay. At any rate, we have now these reciprocal definitions. And what are you expected to be able to do? Okay, so here's the unit circle problems that would be given on the final. And you would have probably about a dozen of these particular problems. All should take about 15 or 20 seconds max. I would give you any trig function. I would give you any standard angle, let's say 3 pi over 4. And then you would just have to evaluate that without using the calculator. Okay, so let me write down a couple of these. The sine of 3 pi over 4, the cosecant of -pi over 3, and we'll do one more. Let's say the cotangent of 3 pi. Okay, and our task is to figure out what these functions for these particular angles are. Now, I think the easiest way to deal with these is think of this as a three-step process. The first step is to figure out where the terminal side of the angle falls. Okay, so what I mean by that is if you have a circle, and if I give you, for example, in this first problem here, the angle is 3 pi over 4, so theta is 3 pi over 4, where does that fall on our circle? Now, this is our starting point. This is our initial side. side, and we're going to be rotating counterclockwise because this is positive, but where does it fall? Okay, so some basic ideas on angles come into play. We know that 180 degrees, 1/2 of a rotation, is pi radians, and we've got 3/4 of a pi here, so that's 3/4 of 180, or 135 degrees. Now, frankly, I don't think that's the best way to do this, but rather to think that pi would run all the way to there, but we're only going 3/4 of the way. So let's just go to here, which is 3/4 of the way. Okay, so this will be our angle theta, 3 pi over 4, 3/4 of a pi, or 3 pi over 4. And here's our terminal point. Okay, so that's first step. First step is where is the terminal side of the angle. Step 2, okay, once we've got that figured out, we need to go to step 2. Step 2 is what are the coordinates? Okay, so what are the coordinates? And this falls back to our second video. You need to have memorized the coordinates for all of these points on the unit circle. And for this particular point, we should know that the coordinates are minus square root of 2 over 2, comma, positive square root of 2 over 2. That would be the ordered pair that fits with that point at the 45-degree line on the circle. Okay, so that's step 2. Step 3, and you're doing all of this sort of mentally, you know, where am I? What are the ordered pairs? Step 3 is what is asked. And what I mean by that is go back to the definition. For this first problem, we were asked to find the sine, and remember the sine was the y-coordinate. By definition, the sine was the y-coordinate. So now we can answer this question. We go and we find the y-coordinate, which is right here, and that will be the answer to this problem. So the square root of 2 over 2. You know, again, that's a long explanation for a process that should take not a long amount of time. Okay, let's do the second problem. We're going to do, again, the 3-step process. Where are we? What's the ordered pair? What's being asked? And we'll try to speed this one up just a little bit. Okay, we're doing the cosecant of negative pi over 3. Here's our circle. We're now rotating clockwise. We're starting from the positive x-axis, but now we're going to be going that way because theta is negative pi over 3. Full pi would take you all the way to there. We're only going 1/3 of the way, which is right to here. Okay, so our angle ends at this location right there. Certainly by looking at the diagram, if it is a negative 60 degrees if you want to think that, but I think it's probably better just to look at this and go, oh yeah, that's halfway on the x-axis here. This ordered pair must be 1/2 and then negative square root of 3 over 2. Okay, so we've done the first 2 steps here. We figured out where's the point on the circle, and now we figured out the ordered pair that is assigned with that point. And the last step of this process is what is being asked. Okay, so again, go back, look at the problem. The problem is being asked, what is the cosecant? So quick glance at the definition. Cosecant was 1 over y. So we come back over here. We need 1 divided by the y-coordinate, which is negative square root of 3 over 2. Of course, we're not going to leave it that way. This is the reciprocal of negative square root of 3 over 2, so that would be negative 2 over the square root of 3. And we should rationalize that as negative 2 square roots of 3 over 3. Okay, so that would be the answer to that question. And for the last one, let's go ahead and another diagram. We have the cotangent of 3 pi. Okay, so where on the circle are we? Let's see, we're going counterclockwise again. There's 1 pi. There's 2 pi's. 2 pi is 1 full rotation, 360 degrees. 360 degrees, but now we're going 3 pi, so we come back around to here. So our terminal point is going to be the left side of the circle. The ordered pair there is -1, 0. So we figured out where we are, we figured out the coordinates of the point, and the last thing we need to do is figure out what is being asked. Cotangent, again, check back to the definitions. By the way, do you think you need to have these 6 definitions absolutely memorized? And that would be affirmative, right? You got to have those. We need the cotangent, which is x over y. Okay, so we go back to our ordered pair. We're supposed to have x over y, but looking at these ordered pairs, that would lead to the nonsensical expression -1 over 0. Please don't write that. I'm not a half camper if I see anything that hits division by 0. So we might think that, but immediately we should go, this expression is undefined. Technically, it's incorrect to write equals. I mean, equals is used for numbers, so this doesn't even make any sense. Equals undefined. I would much rather you just scratch the equal sign and write the cotangent of 3 pi is undefined. Okay, so there's some unit circle questions. Yes, you should certainly go ahead and memorize the angles and the definitions for all the standard angles on the unit circle. Okay, so unit circle, increments of pi, you need to have pi over 6, you need to have 2 pi's over 6, you need to have 3 pi's over 6, you need to have 4 pi's over 6, and you need to have 5 pi's over 6, and obviously 6 pi over 6, both positive and negative. So going the positive or the negative direction clockwise here, this would be -pi over 6 and -2 pi over 6, -3 pi over 6 straight down, -4 pi over 6, and -5 pi over 6. And then going back to here, this could also be -6 pi over 6. Notice that these are all 30-degree increments. So think 30 degrees or 60 degrees or 90 degrees. Okay, and likewise going the other way. Okay, now, even though I've written these as pi's over 6, make sure that you understand this would normally be written as -pi over 3, and this would normally be written as -pi over 2. Just reduce the fractions. This would be -2 pi over 3. This would be up here 2 pi over 3, and so forth. Okay, pi over 3. So there's all your 30-degree, 30, 60, 90 increments. The other standard angles would be the 45s, and I'll throw those in here with the green line. That's pi over 4. This would be 3 pi over 4. This would be 5 pi over 4. These fall in between the 30, 60, 90s, 5 pi over 4, and over here, 7 pi over 4. Okay, and then just make that up with the idea of the halfway positions, and you should be okay. This is halfway up, halfway down, and then halfway over. So these are the ones that have half for the x's and half for the x's. Okay, certainly memorize that. Sleep with it under your pillow. Those have to be very, very, very quick when you encounter the exam. Okay, let me stop the video here, and for the next one, we'll go to the graphs.